In this section, we're going to start looking at data and computing things with data, the most important being the mean. You probably know the word as average. It's the same thing, but in this class, we'll use the word mean for average. So suppose I give you a bunch of data. I'm not going to tell you what it is, but let's just say I call it x1, x2, ... and I don't know, it ends somewhere at x sub n. Then we write the mean in the following fashion. X with a bar over it, and that is the sum of the x values all the way up until the end. And you divide by the number of data values. So there's a shorthand for this. And it looks like this. That notation on top, that little symbol before the X, is called sigma. That's the Greek symbol, and we always use it for adding. So it's just a shorthand notation. We'll use a shorthand like that for a lot of things in this course. But in any case, let me do an example with some data. So here's my data, 1, 1, 1. And then I have 2, 2, 3, and then I have a total of 5 4s. And so the mean, I'm simply going to add up all the numbers on top. 1 plus 1 plus 1 plus 2 plus 2 plus 3. I think I had a total of 5 4s. Let me put one more 4 in here. And then I have 5 4s. And I'm going to divide by however many numbers there were. Let me see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like 11. So on the top, I get, let's see, 5, 7, 10, 30. And let's see what that number turns out to be. I think I'll just use any calculator on here so you can see the computations. So I'm going to do 30 divided by 11, enter. So in this class, I'm going to generally go 4 decimal places. So I'm looking at 2.7273. So if I say nothing, my default will be 4 decimal places. You can set your calculator to 4 decimal places. Now notice something. Let me notice something here. I could have gotten that same answer in the following format. Notice that there are 3 1s. So I could have done 3 times 1, and there's 2 2s. There was 1 3, and there was 5 4s. And that was over 11. So this is another way of accomplishing the same thing. In fact, if you look at something like this, let's put my data and the frequency. What were my data values? I had 1, 2, 3, and 4. So I have 1, 2, 3, and 4. The frequency of the 1 was 3. The frequency of 2 was 2. The frequency of 3 was 1. And finally, the frequency of 4 was 5. So this here, and so what we might write for shorthand for this, when you have a frequency distribution like this, is we probably write this. Let me call this x. So we'd have x times f. This one is f divided by, and then you have to divide by the sum of the f's. So if you look, let me actually do this here. Let me do x times f so that you can see where all the values come from. 1 times 3 is 3. 2 times 2 is 4. 3 times 1 is 3. And then finally 4 times 5 is 20. So I'll need to add up these two columns here. Here we already know this adds up to 11. And this one here adds up to 30. So this is how we get our 30 divided by 11. Now you can use this exact same formula inside Desmos. I have yet to find a really good way in Desmos of getting this with a frequency distribution, but let me pop over to Desmos. I don't want this page. Come back here, Desmos. I know you're in there somewhere. So once again, let's type in a table, and it will automatically start it for you. And I'll put the data that I had in there. And then I'll put the frequencies over here. And now I can come over here and what you can type on the top is this total. And you could do x1, y1, so it'll take the product of the top. And this total means it'll add them all up. And then we can divide by the total of the frequency column. And I don't think it likes the fact that because mean is a term that it uses. So let's use the letter M then. So there, it gives me my value. Mean is held by the computer or this program for something important. So notice that this is the sum. That total is like the sigma, and then you have your x times y. These x's were the data values, and these y's were the frequencies. If you want to make it, you can call the y's. You can go up here, type in that spot, and you can type in frequency if you want, and then you have to put frequency down here. I'm not so sure that you want to go there. Maybe you might want to just put like the letter F or something. So you could put like an F1. So if I backspace and put an F, this might be more desirable to you because this looks more like the formula now. And you get it back that way. So you might like this way better. Whatever you do, don't erase these subscripts. Use them because that'll keep things organized. You don't want to try to get rid of them because you will run into something like this mean problem and you might grab something that is held for special purpose by the program itself. All right, let me come back to here. I've done this a number of ways. Hopefully you get the idea. It's a pretty simple concept. Next example, I'm going to write it like this, x and f. And so my data will be the x values, 0, 1, 2, 3, 4. And the frequency, we have 5, 15, 6, 3, 1. Compute the mean. So to do that then, if we're going to do it by hand, I'm going to calculate a new column, x times f. And then to get your mean, you're going to take the sum of the x times f's, and you're going to divide by the sum of the f's. So I need a sum down here, and I need a sum down here. So the f, let me see, we got 20, it looks like 30. And over here, I've got 27, 36, I got 40. So this is going to be 40 over 30. That's 1.3. Let me do it in Desmos for those of you that like to do them in Desmos. I'll put in my, here, I'll edit this table here. Here we went from 0, 1, 2, 3, 4. In my frequency list, 5, 15, 6, 3, 1. And you can see I do this. While we're here, you're able to tell where the median is also. That's another measurement of centrality, if you will. Come back here. We know that there's 30 data values, and the way they look is this. We have 5 zeros, so it looks like this. I'm going to write it one time to explain this. 2, 3, 4, 5. And then we have 15 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm going to stop there because there's a total of 30 data values. That means the center of this data are data values 15 and 16. Well, let's find out where data values 15 and 16 is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These two guys right here. This is X15 and X16. That's those two numbers. If you take the average of those two, you can see that the median is going to be equal to 1. So these tables really make it quite easy to tell. I could have told that before also, because over here, if I keep track of how many values I have up to a point, I know that by the time I'm finished with 1, I've already used up 20 data values, which is farther than halfway to 30. That's why I knew all I had to do was go through the zeros and ones. Although you don't need to do all this, you should be able to see that the data from 5 through 20, or actually data values 6 through 20, are all ones. And then you would know that data value 15 and data value 16 are both ones. Next, we're going to look at a grouped frequency distribution. This is when you don't have as much data as you want, but you have I would say a good amount of data. You can get a pretty good idea of the mean. It's just you can't get an exact value for it. So I'll show you what my X values are. The first class starts at 0 and goes to 3.5. The next class goes from 3.5 through 7.5. And then we have 7.5 through 11.5. And 11.5 through 15.5. And then 15.5 to 19.5. So we call these group frequency distributions because these are a range of values. And so like my data is probably whole numbers. So I could have like numbers like 0, 1, 2, and 3 in this class. In this class, I probably have 4, 5, 6, 7, possibly. So I'm going to give you that, and then I'm going to give you the frequencies. The frequency of the first class is 3. The frequency of the second class is 7. The frequency of the third class is 12. The frequency of the fourth class is 7. And finally, the frequency of the last class is 9. So there's my frequency list, and there's my X list. Now, you're going to be told to estimate the mean. To estimate the mean, we find the midpoint of each class. So for the midpoint then, what you do is you take the average of 0 and 3.5. So I could take the average of 0 and 3.5 will end up being 1.75. Then if I take 3.5 plus 7.5 and divide it by 2, I'll end up with 5.5. Now the first category here starts at 0, so it's not exactly the same size as the other bars, but they do go by 4s thereafter, so I'll just be able to put these in like so. So those are the values that we're going to use. Let me call it M for the midpoint. So what you're going to do then is you're going to add up all these frequencies. And you're not going to do that, but you are going to do a column that is X times M. So, I'm sorry, M times F. And the way I'm going to do that here is, let me move this stuff here. Move this to the side. So you know where those things came in. I just want some room over here. What we do then is we make another one. We take an M times F and make another column. So I'm going to have 3 times 1.75. I believe that's 5.25. 7 times 5.5, I believe, is 37.5. 12 times 9.5 is 114. I will check these numbers in a second. 91 plus 3.5 is 94.5. And then finally, oh boy, 153, 157.5. Where's that calculator? Let's check these numbers. I like it. Can I make this thing smaller? Yes, I can. But no matter where I go, it wants to block my numbers. All right, so let's start. 1.75 times 3. That was right. 5.5 times 7. 38. That's a good thing I checked. Then I have 9.5 times 12. 114, I got that one. At 13.5 times 7, 94, got that one. And then we have 9 times 17.5 and 157. Good, I got them all. I'm going to want the sum of that column too. So first, let me get the sums of the F's. I'm not going to put I'll put it over. Let's do that, it's fine. Let's add these up then. So basically, I'm going to treat the midpoint as my data. These are my data values for doing this computation. Let's add these up. I got 10 plus 12 is 22, plus 16 is 38. And then this one, let me go ahead and just use the machine to do that. 5.25 plus 38.5. Plus 114 plus 94.5 plus 157.5. What would all that add up? 409.75. So we have sum of the M times F. Don't remember the number, and I saw it 2 seconds ago. 409.75. And then when I go to find the mean, I'm going to take the 409.75 and divide it by 38. And let's see what we get for that. Well, let's see, 4 decimal places, I've got 10.782 10.7829. 10.7829. Let's pop into Desmos. And I'm just going to edit this table, I think. What I'm going to do here is I'm going to put those mid-range values. So I'm going to put 1.75. Go down. The next one was 5.5. Go down. 9.5. Down. 13.5. I think I'm going to have the same exact number of data values as I had before. I got those. Now let me get my frequencies in. 3, 7, 12, 7, 9. So these things will update while you're doing it. That's why you could just leave this open while you're doing all of your problems, and you'll never have to go and recreate this table. You can just keep editing it. Next, we have a concept called the mode. The mode's pretty simple. It's the data value that occurs the most. It could be more than one. So it's the data values that occur the most, except there's a couple of complications there. It's not so simple. Let me grab an example out of the book. To find the mode here, we simply note how many times each data value occurs. So if I make a table up, X and the frequency, I simply want the one that has the highest frequency. So I have 0, 1, 2, 3. I'll just put the numbers I see. 4, 5, 7, 8. Looks like I got a 9. 10, 11, 12. Now let me put the frequencies in there. So the 0 occurred 3 times. The 1 occurred once. The 2 occurred once. The 3 occurred twice. The 2 occurred once, not twice. The 3 occurred twice. The 4 occurred twice. The 5 occurred twice. The 7 occurs 4 times. 8 occurs 3 times. 9 only once. 10 twice. 11 twice. And 12 twice. So here, we simply look at the one with the largest frequency, and that's it. So the mode equals 7. Now, there are complications to the mode. It's not that simple. If we don't have more than one piece, so how do I want to say it? If for each piece of data we have, we only have one data value, then they won't consider that to have a mode. So if every data value only occurs once, there's no mode. Now, you could have multiple data values occurring most often, and so if that happens, then if you have more than one mode, so if I don't know, if one data value occurs 10 times and another data value occurs 10 times, and 10 is the most number of times they occurred, then certainly you would take both numbers to be your mode.